Okay, so let's take a look at this example. I have an L-shaped object right there, and this object is formed by welding two slender bars. Each bar has the length of L, so they have the same length. They are welded together to form an L-shaped object. And what I'm trying to do is that I want to find the moment of inertia of this object about this axis, LO, which goes through point O. So that's the goal. Now, what do? I follow the steps I just mentioned in the previous video. I have a composite object. I can look at it as a composite object. I'm going to divide this object into simple objects. In this case, I'm going to divide this into two slender bars. Right? I'll divide it from here. That would be, I'll call this one bar 1, and I'll call this one bar 2. So now I have two slender bars. So first step was to divide it into simple objects that we can calculate or find their mass moment of inertia. Now the second step is to find the mass moment of inertia for each part, well, about this axis. So for a slender bar, we saw it before in the first example. We found what the mass moment of inertia for a slender bar is about its center of mass. So center of mass for bar 1 is here, and center of mass for bar 2 is here. So I know the mass moment of inertia for bar 1. I can calculate that about this point, and I can calculate the mass moment of inertia for bar 2 about this point, which are their center of masses. So center of mass, or those points are the center of mass. Now, what I need to do is that I have to find the mass moment of inertia for each bar about this axis. What I'm going to do is that I'm going to use parallel axis theorem. So let me put it this way. So we divided that now. 1, divide the object into two bars. Divide the object into two bars. 2, find the moment of inertia of each part. Find the moment of inertia for each part, or each bar, better to say, for this example, each bar about L naught. LO, that axis. Now, I know what the moment of inertia is about the center of mass. So for bar 1, I would say let's identify that with IO1, right? Mass moment of inertia around axis O for bar 1 is equal to mass moment of inertia of bar 1 plus whatever is the mass of bar 1 times the distance squared. And now what is the distance? Well, here is the axis that passes through center of mass. So that would be my distance in this case, right? This is D. This is D1. What is D1? Is L over 2. So this becomes, well, so this becomes, well, the first term is the mass moment of inertia for the slender bar about its center of mass. 1 over 12 m L squared. The length is L, the mass is m. You're given. Plus m multiplied by the distance squared, and distance is L over 2. So that would be distance squared. So from there, I can find the mass moment of inertia. If you do the math, you'll get 1 over 3 ml squared. Right? Now that was for bar 1. Now for bar 2, well, let's go this way. IO2 now, mass moment of inertia about axis O for bar 2 is I2, mass moment of inertia for bar 2 about its center of mass, plus mass, I'll call it D2 squared, the distance between the center of mass and the axis. And that distance is for bar 2 is right there, right? This is the distance I'm looking for. That would be D2. Now what is D2? Well, this is the right triangle here. This is L, and this is L over 2. So I can actually find D2. D2 would be the square root of L squared plus L over 2 squared. I'll just take it from there and put it here. Put it in the equation. So this becomes 1 over 12 m L squared. It's the same thing for slender bar about the center of mass plus m times d2 squared. So d2 squared, I can get rid of this square root. This becomes L squared plus L over 2 squared. If you do the math and simplify this, you'll get IO2 is equal to 4 over 3 m L squared. So I divided the part into two, this composite object into two parts, two bars. I calculated the moment of inertia for each bar about the axis that we're interested in, and I use that relationship between two axes when they are parallel and we know the distance introduced in the previous video. And the third step would be just sum up the moment. So sum up the moments. In this case, there is no cutout or hole, and these two are objects that they have they're part of the composite object or body. So IO is equal to IO1 plus IO2. 1 over 3 ml squared plus 4 over 3 ml squared. If you do the math, you'll get 5 over 3 ml squared. And that would be the moment of inertia for this L-shaped object about this axis, LO.